So, okay, today's topic is elastic load balance. So, what is load balancer? Load balancer is like the elastic load balancing service allows you to distribute traffic across a group of instances, enabling you to achieve high availability in your application. Okay, that means this supports routing and load balancing of a hypertext transfer protocol. Okay, that means it will be converted in. It will be used in HTTP or HTTPS or TCP or SSL. That means SSL means sockets layer, and TCP means transmission control protocol. Okay, so this load balancer is used for to uh, to overcome this load balance. That means, for example, let's take this. We created one instance. Okay, in that instance, what will happen? We will run the application. For example, take this Instagram application. Okay, for the initial stage, what will happen? Very few members will use, but day by day, what will happen? Users will be increased, right? So then what will happen? This instance might get delay, or it get down. So to overcome this solution, we'll use this elastic load balancer. This elastic load balancer, what will do means, it will see. Let me. I have created 5 instances. Okay. In that instances, what will do? I will create this load balancer before that. Okay. I will attach this load balancer to the 5 of the instances. Then, for example, there are 100 members of users. So what will do this load balancer? It will divide the all the users. Like for one instance, it will give 20 users. For another instance, it will allocate 20 members. So like that, it will divide equally. Okay. For example, in case users are increasing, then what will happen? It will load balancer will segregate the members equally. So like that, this elastic load balancer will use. Okay. And also this elastic load balancer supports a health checks for instances to ensure traffic is not routed to unhealthy or failing instances. So that means if anything happened to that particular instance, what will happen? By I mean, See, sometimes you might know this phone pay or Google Pay server is not working. What will happen at a time? Too many users are using at the time. What will happen? It might get chances to. I mean, uh, I mean, something will happen to that. Stance. So then, what will happen? We cannot use that phone pay or Google Pay at the time, then we get some issues. So to resolve that solution, we'll use this elastic load balancer. Uh, for example, users directly connect to instance, or might it will get crashes. The application will be unavailable, right? So for that, we'll use this. And this ELB distributes request to multiple healthy instances in different available zones. If one instance fail means this traffic will automatically rerouted to another available zone or another instance. So like that. And also using this elastic load balancer will have high availability. Why? Because if anything happened in one region, one available zone, or anything happen to this any instance, then what will happen? It will automatically create the instances, and it will segregate the users. So like that, it will use. So like that, it will have a high availability. And also it has a elastic scaling. That means if you want to increase the instances, then it will increase, or if you want to decrease the instances, then it will decrease. But when this will happen means when you are enabling this auto scaling. When you are enabling this auto scaling, what will happen? It will either increase or either decrease. So like that. But see, I will tell this auto scaling also in the next session. But today's topic is only load balancer. Okay. Uh, if you want to create auto scaling means it definitely should create this load balancer. Okay. If you are using a load balancer, no need to use of auto scaling. Okay. Note this point. While explaining this auto scaling, I will tell you deeply. Okay. And also it distributes traffic easily. Hello, can you hear me? Hello. Yeah, okay. So like that it will have elastic scaling. So and after this will it has more security. See, we are creating the VPC. In that VPC we are creating this load balancer. Even though if you are keeping our instances in this directly open, what will happen? Might be get users will get any issues, or might IP address will dispose openly, right? So if we are creating like this for one public subnet and one is private subnet, we are not giving internet access to the private subnet. Okay. But we are not doing any our work in public subnet. Whatever the work we are is there, that all that work will store in private subnet. Okay. But coming to this public subnet, what we'll do, we'll only attach this load balancer in public subnet. So if anything, if anyone got the IP address of a public subnet, what will happen? They can see only this load balancer, and this load balancer will created through DNS name. DNS name means uh, like see, for example, take this Google. What will happen? They will buy the name, and that name will I mean see, for example, take this Facebook. Okay. What will happen? They will buy this name of Facebook through the DNS. Okay. Or you can buy this name in GoDaddy or anything website. By using that website, what will happen? They will allot you a one name. Like see, for example, you are keeping a shop. What will happen? You will just give one name, right? In the same way, we are buying one name in website. So like that, we will buy one name and we will attach that name in elastic load balancer. But here, what we'll do? Just it will create one name. We'll use that name only. Same as like previously we are using this VPC, right? In the same way, here also we'll use. See here, I already told you, right? Like if it will ELB will share the users equally. Uh, Let me tell you like this also. See, for example, if you are using Flipkart, sometimes they will give you some offers like big billion days or like that, right? On the time, what will happen? All the users will use at a time. On the time, what will do? This load balancer will allocate the uh, I mean users into equally. See here, if you are maintaining only two instances, then what is doing it 20, it's separating like 25 under 25. For example, if you are using 8 instances, then what it's how it was converting like 6.25. Actually not like that. It will for example take this 101 for 8, what will happen uh, or the 181 like that, 20 20 20, and it will come from the starting. Okay, like means 21 20 20 20. If users are increasing, then it will allocate the members to this particular instance. So like that. So this is a load balancer. After that, how it will work means it will work through OSI layers. Okay, through these OSI layers only, we will. I mean, what type of load balancer we have to use. Coming to this OSI layer means this OSI layer will have this see, the OSI model is a conceptual framework that defines how data is transmitted between two systems over a network, and it divides network communication into 7 layers, each with specific responsibilities. Think of it like postal system. Writing a letter, putting it in an envelope, sending it. See, this is like example. Okay, so this is an example like how we use the postal system. So like that. So this is OSM means it, I mean each layer of the OSM model interacts with different layer directly above the above and below. Okay, like transmitting data in a structured manner, or I mean network professionals are troubleshoot issues, or be isolated to a specific layer. The OSM model serves universal language for networking, providing a common ground for different systems to communicate effectively. And the modern internet is not based on OSI, but on the simpler TCP or IP model. However, the OSI layer is model is still widely used as it helps visualize and communicate how networks operate. Okay, and this OSI model can shade understanding of complex systems like universal language for networking, enabling different network devices and software to communicate. And also by dividing communication into 7 layers. And also it allows a network professional to isolate and troubleshoot problems effectively. See, these are the 7 layers. So see, for example, I'm the user. So what will happen? It will from application layer. It will start for me. Okay, like that. So coming to this application layer, what will happen? It will create one. I mean, it will interact with the server, and that server, what will happen? It will access the. I mean, how can we say? Yeah. Mm. So that server, what will happen? It will navigate to this presentation layer. So in this presentation layer, presentation layer, that data will be is it in I mean this HTTP or HTTPS is in encrypted or decrypted state. Uh, like see for example, I'm searching in the browser as for YouTube or something. Okay, what will happen? It will create, I mean it will send the server to this guy is using like HTTP protocol. Then what will happen? For HTTP, it won't any encryption. It will be by default decrypted, right? For if you are using HTTPS, then what will happen? It will in encrypted mode, right? So like that, it will give you. I mean, it will send the request from your system. Okay, like that. This application layer will work. After that, the presentation layer, it what it will do, it will verify this server, how they are using the browser like a HTTP or a HTTPS. So from that, it will give you the details. So that means it ensures usable format or not. And coming to this session layer, what it will do, it manages the what you are giving the what you are searching in browser. So that manages this communication sessions, like it will start or maintain, or it can end. And next, transport layer, it ensures that reliable delivery of data from like TCP or UDP. And also, if is there any errors, means it will show you errors like 404 or 402 errors, right? So like that, it will take. And coming to this network layer, that means it will check that IP address of the server. That means from which uh, system it's taking this. I mean, uh, request. What the user is requesting in browser. So from that system, it will take the IP address. And the data link layer, that means handles error detection like MAC address or frames. From the network layer, what will happen, it will just check this from which IP address it came. Coming to this data link layer, that MAC address is really available or not, like that it will check. And coming to this physical layer means nothing but routers or whatever the internet connection is getting through wire. So like that, it will check. Okay. And types of ELB. Okay, these are the actually we'll use only application or network or gateway. These three load balancers will use mainly. Okay. In this, these are the types of load balancers. Like, I mean, which application load balancer want to use? I mean, which load balancer? See, for example, for a few of load balancers will use complete 7 layers. For some applications, it won't use all the 7 layers. It might use 4 or 5, like that. So like that kind of you will select the which type of load balancer want to use for that particular application. Okay. So in that what will happen, coming to this application load balancer, let's see what is mean by application load balancer. That means it will operate with all the 7 layers. That means a HTTP or HTTPS. And it is ideal for routing traffic based on advanced criteria like host name, path, query, and HTTP headers or source of IP address. Okay, it supports features like HTTP or web sockets or server name indications and user authentication via SAML or social identity providers. And it is the best suited for load balancing. That means whatever the your application is, you can use it application load balancer. So like that. And application load balancer route traffic to targets means here instances. Okay. Within this VPC based on the content of request. And it has 7 layers of load balancing. So you can load balance of HTTP HTTPS traffics. Okay. And you can create and manage security groups with load balancing to provide additional networking and security options. And also it can stick the sessions or mechanisms to route a request from the same client. And also it has a more host field and path URL, HTTP header or HTTP method. So like that it will be there. See, this is. And coming to this network load balancer, this is operates with for TCP or UDP. So and it is designed for high performance. Okay, and the best suited for load balancing of TCP traffic where extreme performance is required. And this network load balancer are capable of handling millions of requests per second while maintaining it, but it has low latency. That means, uh, see, if you are requesting in for YouTube, then what will happen? It will take very slowly. I mean, it has to take too much of time to load. Okay, and coming to this. Gateway load balancer. Load balancer means GWLB. It is used to deploy third-party virtual network applications such as firewalls or intrusion detection systems or into the network traffic path in a scalable and manageable way. It makes easy to deploy and manage your third-party applications. It gives you one gateway for distributing traffic across multiple virtual applications while scaling them up or down based on the demand. And this eliminates point of failure in your network and increases availability. This gateway load balancer can be used for generic networking virtualization, and also this will use for most of database applications like deep, I mean, whatever the data analyst or they will do, right? Those kind of applications will use only this one. So like that. And coming to this uh, classic load balancer. Uh, Actually, this is a very old technique. That means they will use. That means this type that supports both 4 layers and 7 layers. Uh, but 4 layers and 7 layers. Mm, just a second. So coming to this classic load balancer. Mm, it has four I mean four layers and 7 layers. Okay, but we'll use only for now AC, I mean ALB. And it has the more applications and such as forwarded and sticky sessions. So you can also use uh, stick layer for load balancing for applications that purely on the TCP protocols. Uh, So actually, the main thing of this load balancer is to manage the users. I mean, the application users easily. So if you are actually this is an very competitive world, right? So in this world, what will happen if anything issues we face in this application? Then simply we will choose another application, right? So for that purpose, what they are doing means they are every time developing their application usage of users. So like that, this will ELB will use. So main thing is, but you will get a better understand while I was giving you a practical session. Okay.